grade 11 is kind of a continuation of grade 9 and grade 10. Nothing much new is there, but moreover, a lot of understanding concept. So, and as another thing, in your O-level paper puthe, about 50% of your O-level paper is going to be on grade 10 as well. So you cannot forget your grade 10 work. That will be very helpful for you to get a good result. Anyway, let's start up our new lesson today. Yeah, real numbers. Yep. So, what are these real numbers? And we are going to learn about what number systems are there. And after that, we will go to the lesson called surds. Okay. Now, Putha, in mathematics, yeah, all the numbers are known as Puthe. Now, this is a little bit more than what you are meant to know. Complex numbers. Complex numbers. All numbers in the world, we call it as complex numbers. Yeah. So complex numbers is the main. These complex numbers, like when we go to a sports, like where something where all sports are there, we call it a sports complex. Yeah. Or when we go to a shopping complex. Yeah, where every shopping thing is there. Yeah. So like that, we call not shopping complex numbers for all numbers which we have. Okay, these all numbers which we have can get divided into two main parts. Yeah, gets divided into two main parts. Yeah, one is real numbers. Real numbers, and mathematically, Putha, we denote with a letter R with a line here. When we are writing in ink, we write it like this. But if you are typing, you just write a R. We denote with the letter R. And the other one, we don't say it unreal number because opposite of real is unreal number. But we don't say it unreal numbers, but we call it imaginary numbers. Imaginary numbers. Yeah. So there are two types of numbers. What are they? Real numbers and imaginary numbers. Imaginary numbers, Puthe, is something, yeah, y'all might have seen it. Yeah. When y'all even look at it back in old days, Puthe, Internet Explorer also had it as the logo. Have you all seen this weird eye symbol? Ever? This weird eye symbol? Yeah? That is about imaginary numbers. Yeah? If you ever do combined mathematics under pure maths, you are going to learn it. But further extent, an engineer needs to know about imaginary numbers, and obviously a maths specialist person needs to know. Even under engineering, only electrical engineers and aerospace engineers mainly learn about imaginary numbers because electricity, most of the things we use imaginary numbers here and there to understand how things work. Yeah. Apart from that, if you do civil engineering or anything like that, I don't think you will really need it. I'm not sure. But yeah, imaginary numbers are mainly used in anybody who is related to electrical type of things. Anything. We don't need this guy. That is unnecessary for us. We are going to real numbers. That is our lesson. Real numbers means, Putha, a number which is there in its own number format. Yeah, a number which is there in its own number format is real numbers. It's pretty much, it is a number which is there for real. That's what it means. Real numbers, Puthe, mainly gets divided into two main parts. Now, this is the place where you need to give your full attention. Now, make sure that you write down with me. Yeah. You need to give more attention to this part. Yeah, real numbers puthe gets divided into two main parts. One is rational numbers, and the other one, which we denote with a letter Q, but if we are writing, we write a Q with an extra line. I don't know why we do that. We put an extra line. Even R in real number, we put an extra line there. Yeah, rational number, and the other one is irrational numbers. Now, rational and irrational. What does it mean by a rational number? Irrational number means, yeah, Q dash, complement. Can you remember since when we were doing it? Dash means not real. Q dash. Yeah. Rational numbers means, yeah, a number which can be written as a fraction. So any number which can be written is P over Q format. That means the numerator and a denominator is known as rational number. Any number which can be written as a fraction is known as rational number. Then an irrational number means what? A number which cannot be written in the P over Q format or cannot be written as a fraction. What are these numbers? The easiest way to analyze or investigate whether it's an irrational number is if the number is never ending. Never ending and has no pattern at all. Yeah. If the number is never ending and has no pattern at all, we call it puthe a irrational number. Can you all remember any number like that? I'm sure we did a number. 5 is an example for irrational number puthe. Or even the Euler's number, the E. In your calculators, you might have seen the E letter. Yeah, that's called Euler's number. Is that? Even puthe a non-square number root or a root of a non-square number. As an example, square root of 3, square root of 5, square root of 7. Yeah, these all are puthe irrational numbers. You don't know what that number is. We can't find that number part. Rather than working out for it or using a calculator or working for it. Yeah, you can't straight away divide it and get the answer straight away. No. Yeah, so a non-square root of a non-square number is a irrational. Got it? That's what an irrational number is. Now, rational numbers gets divided into another two parts. Rational numbers gets divided into another two parts. One is called integers, which we denote with the letter Z, and the other one is rational decimals. Yeah. Integers means, this is a very important part. When we were doing fractions also, I told you. Yeah, a whole number or a normal number means a number where the denominator is what? Denominator is in integer, the denominator is what? 1. Yeah. Fraction. So integer means a fraction where denominator is 1. Yeah, the rational decimals are just normal decimals. Those normal decimals are also put there. Yeah, a non-decimal number is integer. Decimal number goes under rational as well. The first one is terminating decimals, or some people call it non-reoccurring, which is a very bad way to say it. Non-reoccurring decimal. Yeah, terminating decimal. Terminating is the better word, but in your textbook it says non-reoccurring. Yeah. So terminating or a non-reoccurring means what? Terminate means what, Pute? Yeah, terminate means stopping. It has a stop. Yeah, as an example, a half. Half is 0.5 and that's it. Yeah, or a 1/4. That's a 0.25. It got an end. Yeah, that's a terminating decimal. And then obviously the other one is reoccurring decimals. Yeah, reoccurring decimal means, Pute, a number which keeps on going. Yeah. Now here it's not like what do you call irrational numbers. It will never end, but it has a pattern. Yeah. Reoccurring decimals don't have an end in, Pute, but they have a pattern. So as an example, something like 1/3. 1/3 looks like 0.3333 dot 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 dot. It keeps on going through. On those cases, Pute, we just write down 0.3 and a dot on the top. We just write it as 0.3 and a dot on the top to say that this decimal number, yeah, is reoccurring with this reoccurring dot, we call it, yeah, to say that it got a reoccurrence. All good, Pratap? Yeah, tell me. Sorry? Goes off with different numbers. You mean like 0. Like a 1.232323 something like that? Yeah, I'm coming to that. Give me a second. I'm coming to that. The next thing, also we can also see, Pute, sometimes we will get questions just like Dovina was asking. Sometimes we can get like a 13/7. Yeah, a decimal number like a fraction like this. Now let's have a look, Pute, how to write this 13/7 as a decimal. Yeah, 13 divided by 7, decimal point and couple of zeros for fun. Actually, you will need more than couple of zeros for this question. It will be a very humongous reoccurrence. How many 7s can go into 1? 0 left over 1. How many 7s can go into 13? That's a 1 left over 6. Decimal point comes up. How many 7s can go into 60? That's a 56, which is 8 left over 4. How many 7s can go into 40? That's a 5, 35 left over 5. How many 7s can go into 50? That's a 49, which is a 7 left over 1. How many 7s can go into 10? That's a 1 left over 3. How many 7s can go into 30? That's a 28, which is a 4 left over 2. How many 7s can go into 20? That's a 2, 14 left over 6. How many 7s can go into 60? That's a 8 left over 4. How many 7s can go into left over 4? 40, that's a 5, 35 left over 5. How many 7s can go into 50? That's a 7 left over 1. Yeah. Can you all see something happening now? Can you guys see something happening here? Yeah. Can you guys see the pattern continues here? Yeah. Left over 1 and then 1 left over 3, 4 left over 2, again 2 left over 6, then again 8. Can you guys see Pute here? 8, 5, 7, 1, 4, 2. 8, 5, 7, 1, 4, 2. Can you see? It's reoccurring. It's happening again and again and again and again. So then this guy Pute, we can write it as the answer is going to be 1.85714. Now, back in, if your teacher is an old teacher, they will say to write a line on the reoccurrence. This is the old technique of doing it. But if your teacher is a person who is born after probably 1990s and a person who at least keep themselves updated with modern books, then that person will say, yeah, to write the reoccurrence dot at the very beginning of the reoccurring place and at the very ending of the reoccurring place. So even that makes sense to us. It means 857142 reoccurring again and again and again. Do you guys get it, Pute? Yeah. Okay. Quickly write down until there before we go to integer part. Namaputa, I hope that I pronounce your name properly. Did you understand everything, Pute? Can you hear me properly? I think you are new to the class, right? Good, Pute. Write it down. Are you guys done with writing? Yeah. Oh, wow. That's cool. Then let's go to the next part about integers. Then Pute, the integers gets divided into, again, two main parts. Now, is it going to be asked in the exam? But it's there in the syllabus. So I'm teaching you, and it is a good thing to have in the syllabus. I like this. Okay. Integers gets divided into two parts. One is whole numbers, and the other one is negative integers. Now, negative integers, Pute, is denoted with a Z with a negative on the top. Z with a negative on the top. And you guys know negative integers means starting from -1, -2, -3, like that. Now, Pute, whole numbers again gets divided into two parts. Yeah. One is the whole entire reason why we call these numbers as Indo-Arabic numbers, the Hindu part, yeah, which means the 0. Yeah, India is the people who found the 0. So, yeah, there we go, 0, which we denote with a Z with a 0 on the bottom. 0 in the bottom. Yeah. And the other one is positive numbers or positive integers, yeah, where we write with a Z and a plus on the top. That means whole numbers, how do we denote it, Pute? Z with a 0 and a plus. Positive numbers and 0 is whole numbers. So if somebody asks you, is a negative number a whole number? No. Negative number is not. You can't. Now, positive number, Pute, got another special name. Yeah. We call it as also natural numbers. Positive numbers, which is 1, 2, 3, 4, 5, we call it as natural numbers. Why do we call it natural numbers, Pute? Now, in naturally, you can show it. I can show you here, a 1 pen. Here, 2 pen, 3 pen, 4 pen. I can show you like that. Can I show you, hey, this is a 0 pen or a -1 pen? No, it's not natural. That's not something naturally we do. Hey, I got a 0 pen. Hey, no, we don't do that. Yeah, it's not natural. Yeah, so natural numbers are whole positive numbers. Make sense? So far, so good, Pute. This is how the story about number system works. Yeah. The entire story is here in it. All good? Are you guys done with writing, Pute? So far? Anybody needs more time to write down? No? Okay, let's do a small have a look at it, because end of the day, after this Pute, we are not going to much worry about these things, so I will just ensure that you guys all understood this part very well by doing a little bit of questions with you all. Here we go. Alrighty. Niveta Puta, what do you think the answer for here is? Which of the following describes negative 3? Select all that applies. That means whatever works, tell me. Is negative 3 a natural number? Irrational? Real?
Yeah.
Rational?
I mean, real number, yeah.
Is it a rational?
Yeah.
Yeah. It's in the family of rational as well. Well done. Good job. Alrighty, Dovina Bute. Which of the following is a rational number? There's a one rational number here. Who is that rational number? You are the person who told me pi is a irrational. Zero is a rational. Yeah. The rational numbers gets divided into integers. In the family of integers, 0 is under whole numbers, and whole numbers become 0. Yeah. So it's in the family of rational numbers. Hold on. Namaputa, do you know how to answer this? Is root 17 a irrational number, Pute? Is she there? Hello. Niveta Pute. I don't know, something wrong with the connection, maybe. Yeah? Okay. Govina Puta, what do you think the answer here is? First one is irrational, okay.
That's right.
That's it? Yeah, that's correct. Give me 1 second. නාම කියන කෙනා කොලම් දීලා අහන්න මොකද වැඩ කරන්නේ? She's not answering me. Alrighty. Then, Niveta Pute, what do you think the answer here is? Pi? Yeah, obviously, right? Dovina Puta? Yes? Niveta?
Real number. Real number. That's it.
That's it? That's correct. Dovina Pute?
39.
39. That's correct. Well done. Niveta?
No.
Oh, obviously, right? Then Dovina Pute?
Irrational number. Yeah.
That's it?
Yes.
Good. Niveta Pute?
1352.
1352. No, it's a terminating decimal. They're asking an irrational number. Root 2 only. Yeah. Pi, remember, irrational numbers are pi value, Euler's value, E value, or any root of a non-square number. Irrational means any root of a non-square number or a pi or a Euler. Yeah? Keep that in your mind. Dovina Puta.
No.
Good. Niveta Pute?
0.
That's it?
45 and 66 are rational.
Are they rational? Okay. That's it. Can I submit? You're wrong. Rational number means any number which can be written as a fraction. Even this is a Yeah. Rational numbers gets divided into two parts, integers and decimals. So this is a decimal number. This is a rational decimal number. These are integers. Yeah. All answers were correct. Dovina Pute.
Yes.
That's it. Alrighty, Niveta Pute. What are the rational numbers? Think and answer.
66.7.
66.7777. As I said, they have written a dash there. That's a old teacher, old way of doing it. That's it, right? All the others are not square numbers at all. Okay. Dovina Pute.
Rational number.
It's a rational number. Okay. Integer. That's it. Niveta Pute.
83.
83. Well done. Dovina.
The fourth one.
Fourth one. Okay.
The third one.
Third one. Sorry. That's all. What about the first one, madam? Rational. This is an integer. It's under rational. Any number, Pute, you know is a rational number. Any number which you don't know how to say is irrational. Yeah. Any number which can be written as a fraction is a rational. No? Niveta? Or yes?
No.
No? Okay, that's good. Then Dovina Pute, another, I think 5 more questions left. Is this a whole number, Puta?
No, sir.
No, well done. Niveta Pute? What are the real numbers here?
Everything.
Everything? Perfect. Well done. Dovina Pute, what are the rational numbers? Third one. Lucky you. That's correct. I'm sure that you were not even sure whether they were square roots or not. Here we go. This one, Pute, Niveta.
Real number. Irrational number.
Irrational. Very good. Well done. Okay. Then, Dovina Pute.
Rational number. Real number.
Good job. Done. Perfect. Alright, Pute. Now we are going to the next part of the lesson. Let's write down Pute. Search. Now this is the part you will need. Yeah. Where will you need it? Not as the question itself, but every time you have a quadratic question, search are there in it. So you need this. Every exam you will need it as a by part of it. So what is a surd? Write down Pute. Surd is a number which is represented in a root where the value inside the root is rational, but the answer of it is irrational. What does that mean? That means, Pute, something like, let's say, now, let's talk about square root of 4. What is square root of 4? 2, right? Now look, it's a root value. That's cool. So it's a root is there. Is the value inside the square root is rational? Yes. It's It's rational, no problem. But is the answer after the from it is rational? Yeah, it is also rational. It's not irrational. So is this a surd? No, it's not a surd. Got it? Now then, square root of 2. Square root of 2 is Pute, something which I don't know by myself. So I will take my calculator. Actually, we will learn a method to do it as well later on. Yeah. Actually, you all learned it last year. How to find that long division technique. Yeah. Anyway. So square root of 2 is a 1.41421356 blah 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 blah, never ending decimal number. That means it's irrational. So is this rational? Yes, it is rational. Is this? Yeah. This answer is a irrational. Yeah. So is it a surd? Yes. Is it a surd? Yes, it is. You get it, Pute? Now, think and answer me. Is square root of pi a surd? Let me tell you the value of square root of pi. Square root of pi. Square root of pi is Pute 1.772453 blah 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 blah. Is square root of pi a surd or not? Do you guys agree with it or disagree? Okay. What about Nevita Pute?
But then you can write pi as 22/7.
Oh no! Okay, interesting question. Actually, Pute, the pi value is this. And actually, Pute, 22/7 value is this. Can you see it? 22/7 is an approximation of pi. Can you see? After two decimal places, pi value and 22/7 doesn't apply together at all. Do you get it? It's just a number like this. If I have to multiply pi, actually you all do about physics, right? You all do physics, right? Yeah. We know that potential energy is equal to mgh. Have you done it? What is m? Mass. Yeah. H means height. And g means? What do we use in our exams for g value? 10. But what is the real g value? 9.81. 9.81 something. Yeah. So it's an approximation. Instead of 9.81, we just use a 10. Instead of the real value of 5, which is humongous, we just use 22/7. It's just an approximation to it. Pi is not 22/7. Okay. So yeah, it is not a surd. Why? Even though the answer is irrational, the value inside the root is also irrational. The value inside the root should be rational, but the answer should be irrational in a surd. Does that make sense, Puta? Yeah. So that is the main idea about surds. Then we come to the next part. The next part is making the entire surd into a surd. Actually, that's a very bad language which is used in our textbook. It should be simplified surd. Yeah. So I wrote the same thing which is written in the book, but the real version of it should be making an entire surd into a simplified surd. What the hell does this mean? Let me explain you what it means. Now, Pute, sometimes square root of 35 Pute is square root of 35. Nothing else we can do. We can't simplify that. But as an example, square root of 20. Square root of 20. Square root of 20 puthe, I can write it as square root of 4 times by square root of 5, right? Do you guys understand it? And we all know square root of, because we know 20 is 4 times 5. Yeah, let me explain a little bit of one more extra step. 20 is 4 times by 5, which means square root of 4 times by square root of 5. Yeah, square root of 4 we all know it's a 2. Square root of 5 is square root of 5. Writing it like this is what we call as simplifying it. Whatever the square numbers you can take out of the given number, take it out as the square root of it, but only using multiplication. Yeah. So as an example, another one, let's say we got a square root of 120. 120, what is the best square root number I can take? Can I take what is the smallest number after 120? Before 100. I can't make 120 with 100, right? But then 81, no. 64, no. Then 49, no. 25, no. 36, no. 16, 120, 16. Does it go to 16 for 120? Doesn't it? Let me think. No, right? No. Then the next one is a 9. No. 4. Yes. 4 times by 30. 4 times 30 is 120. That square root of 4 can be written as 2 with the root 30. Did that make sense, Pute? You guys understand how it works? Yeah. So you just need to think about it like that. Yeah? Give your best shot. Yeah. To do this thing, and then this is how the textbook expects you to do it, but after that I will teach you a much easy way to think about it. Try to work out this question, and also maybe after that try to work out 48 as well. Let's work out 48. Think about these two. Your first answer is correct. Well done. Your second answer, you wrote a 2 root 12, right? But Pute, you forgot that even 12 can be written as 4 times 3. So you can take another 2 out of that. So 2 times 2 with a root 3. Yeah? Which is going to be 4 root 3. You get it? Niveda Pute, this square root of 200 can be written as 100 times 2 Pute. Square root of 100 is a 10. 10 root 2 is the answer. Now, as you guys can see, yeah, this thing is not hard, but a hell of a lot of work to do. Yeah, a lot of things to think about. Yeah, so because of that, I made up a small thing. It's a small saying I remembered for myself. What I remember is like this: if you make a group, you come outside the root. If you make a group, you come outside the root. Okay? What the hell that means? So let me explain you like this. Now, let's say that we got the square root of 20, 200 like before. Yeah. What you need to do is, Pute, can you all remember the prime factorization which you might have studied back in grade 7 or something? We used to keep on dividing by prime numbers. Yeah. So start to divide by prime numbers, Pute. First number, the smallest number is 2. You can divide it by 2. Again, you can divide it by 2. Again, you can divide it by 2. Now you can divide it by 5. And now you can divide it by 5. And that's it. Yeah. Now Pute, start to make groups of same two numbers. These two makes the same number, one group of 2. Another group of 5. But this 2 is a loner. Loners always stays inside parental care. Yeah. So this 2 will be left over inside this square root. Yeah. Where the two couple will come out and multiply themselves. Yeah, and that will give you 10 root. Did that make sense to you, Pute? All good? No problems, right? Alrighty. If so, yeah, so in other words, Pute, if you don't make a group, there can be moments where there can be multiple numbers who doesn't make any groups. As an example, square root of 120, which we did before. 120, we know we can divide by 2. That's a 60. 60 can get divided by 2. That's a 30. 30 can get divided by 2. That's a 15. 15 can get divided by 3. That's a 5. 5 can get divided by 5. That's a 1. You can make only one group of 2. And these 2 and the 3 and the 5 are loners. So those loners will be inside the root, while these 2 will come outside the root. So you will get your answer as 2 root 30, because 2 times 3 times 5 is a 30. Got it, Pute? For me, this was a much more better approach to get my answers done when I was going to school, rather than using the other method, which was taking me so long to understand it. Like thinking about square numbers which makes 120, that's something which I had to think about, which I don't want to spend my time with that. Got it, Pute? So far so good? If so, can you guys give your best try to do this question? Yeah, whatever the method you like, I don't mind. This question, this question, this question, and this question. Try to do those 5 questions quickly. And after that, let's go to the operations with surds. Square root of 72. Square root of 72, we got the answer as 6 root 2, right? That's no issue. Yeah. And then square root of 28. So now put a square root of 28. 28 put a, we know we can divide it by 2. That's a 14. 14 can get divided by 2. That's a 7. 7 can get divided by 7. That's a 1. You can make just a one group of 2 put a, and a loner 7. So it's a 2 root 7, not a 4 root 7. Do you get it? That's the only mistake you did. Apart from that, square root of 80 is a 4 root 5. And then square root of 75 is a 5 root 3. And then square root of 147 is a 7 root 3. Perfect. Good job with that. Alright, then there are some moments, okay? There are some moments in maths. They tell you, okay, the root is this. They give you like this, Pute. 2 root 40. On those cases, these are called Pute traps. Yeah, these are pretty much like mines for you all. Yeah, most of the time the students will think, this is simplified because it's a 2 and a root 40 is there. Actually, this is not simplified. Why do I say it's not simplified? Because we totally know square root of 40 can get more simplified, Pute. This is a partially simplified surd. Do you get it? This is not really simplified. On those cases, Pute, just make sure that you simplify this thing really quickly. Yeah, you can take another group of 2. That 2 will come and multiply with these 2, and a 2 and a 5 will be left over. So the correct surd should be 4 root 10. Does that make sense, Pute? There are many questions where they give you like that format and ask you to do the simplification. But before you start simplification of anything, any operation of surd, before you start it, please ensure that you check whether everybody is correctly simplified or not. Is that clear, Pute? All good? Alrighty.
Let us say 40.
No, 40 is what became, Pute. Now 40, when we try to simplify it, yeah, square root of 40 means, Pute, 2 root 10. So we had a 2 already, times by another 2 root 10. Yeah, 2 times 2, that became a 4. Do you get it, Pute? And then, let's learn. Now we learned how to make an entire surd. Entire surd means a surd by itself, a root and a number by itself, into a simplified surd. Now let's learn how to do a simplified surd into a entire surd. How to make a simplified surd into entire surd. This is how I checked your answers, Pute. When you all send me the answers, yeah. What I did was pretty much I look at your answer and then I straight away said whether you were correct or wrong, not by doing the working out like you all. I just did the opposite operation to figure out whether you got it correct or wrong. Yeah. As an example, yeah, you all told me 6 root 2 is the answer for square root of 72, right? Let me show you how I worked it out to check whether you were correct or wrong. Remember, the value outside the root will go inside as a square. The value outside the root will go inside the root as a square of it. Alrighty, and that will give you 2 multiply what is square of 6? 36. 2 times 36, that's a 72. So when you gave me the answer for root 72 is 6 root 2, I said that is correct just by doing 36 times by 2. Did that make sense, Pudha? What happened there? Yeah. Quickly write that part down and then after that let's do a little bit of questions with that. And after that, let's go to operations. Quickly get these questions done. Once you are done with writing, try to do these 5 questions. Let's move on. Alright, Pudha, let's have a look at the answers then. Yep. This one, it's going to be, the 2 comes to inside as a 4, so 3 times by 4, which is a root 12. This 2 comes inside as a 4, 5 times 4, that's a 20. Yeah, 16 times 7, ooh, that's a bad one. 6 times 7 is a 42, 4 comes here, and 11. And then 25 times 2, 50. And 36 times 11, 396. 396. Yep. Anything which went wrong with it? Or both of you all got all correct? All good? Or not really? Nivedita, are you okay? She's done. Then let's go to let's go to Pute. Operations. Operations with cells. Operations with cells. What are the operations with surds? Actually, surds and algebra looks alike when it comes to operations. Yeah. So as an example, let me ask an easy question. Let's say that 2x plus 3y minus x plus 4y plus z. What will be the simplified version of this?
X plus 7x plus b.
X plus 7. 7y plus z, right? Yeah. Just like that, Pute. Yeah. In surds, yeah, the surd form acts like an algebraic term. Yeah. So you can have 2 root 2. Now instead of x, I'm using root 2. 3 root maybe 3 and a minus root 2 plus 4 root 3 plus root 5. Do you guys get it? So instead of z, I use root 5. Instead of y, I use root 3. Yeah. Even here, 2 root 2 minus root 2 will be just a 1 root 2. We don't write 1 there. 3 root 3 plus root 4 will be just a 7 root 4. And then just a root 5 by itself. So we can write down star number 1. Likely surds will add or subtract together. Yeah, like lizards will add or subtract together. Does that make sense, Pute? Just like algebra. All good? Then let's do a little bit of questions together, Pute. Questions here. Can you guys quickly give your best try to do these questions? For me, I don't want everything. I want you all to do this, this and this. Let's do these two together now. Niveta Pute, can you help me out with this question? What will be the answer here? So we can see here root 5s are there. And then the other third term is root 2s are there. Okay. Tell me, Pute, what do you think?
3 root 5
Mm-hmm.
and minus 1 root 7.
Don't say 1 root 7 minus root 7. Just like algebra, we don't use the letter 1. Yeah, we don't say 1x, no, Pute. We just say x. Yeah. But yeah, good job. Very good. Alright. Dovina Pota, can you help me out with this? Now here I will give you help. Root 3s are there. That's a one type of a term. Again, another type of a term is root 2 here, root 2 here. Yeah. And another type of a surd, I should not say term. Surd is a root 5 and a root 5 is there. There we go. Let's start out.
2 root 3 plus
2 root 3 plus
2 root 2.
2 root 2. Okay.
And plus 6 root.
Plus 6 root 5. Well done. Good job. Is that clear for all of y'all? Now, if there was just a number here, like a plus 6, that 6 will come at the very back of it, like a plus 6 by itself. Yeah, got it? Okay, anyway, do these 3 questions, send me the answer. And let's go to unsimplified type of questions. And then let's go to multiplication with surds, and after division, then there's another part for rationalizing. Yeah, I think we can finish off this lesson today itself, which will be fantastic if we can. Will give us 1 no here. 1 plus 5 is 6. 6 minus 2, which is a 4 root 2. And here we will get a 6 root 11 minus this will be 4 root 11. So 4 root 11 and 3 root and negative 2 with a positive 2 root 7. The other one positive 6 root 3 and then 7 root 7. Alright. Yeah, all good for that? Yeah, perfect. Then Pute, the next operation which we have is multiplication with surds. Multiplication with surds. Here we go. So they insert multiplication. If there's a whole number, whole numbers multiply with whole numbers, surds multiply with surds. Alright? Pretty much easy like that. Surds multiply with surds, whole numbers multiply with whole numbers. Same thing goes with division as well. Yeah? Surd multiplication or division, both of them the same thing. Whole numbers will multiply with whole numbers, surds will multiply with surds. Even in division, whole numbers and whole numbers will multiply together, surds and surds will multiply together or divide together. Yeah, here we go. Now first one. Let me do this one with y'all. Yeah, so here what are the whole numbers we have? 3 and a 2, that will be a 3 times 2 is a 6. And then 2 times 3, that's also 6. 6 root 6. Always Pute, once you are done with that, double check whether you can simplify this surd. Root 6, can we simplify it anymore? No, we can't take any groups out of this. So that's it. 6 root 6 is the answer. Got it, Pute? Yeah. Okay. Dominapata, can you help me out with this one? What will be the answer here?
So 15 root 77.
Root 77. 77 can't be simplified because 7 times 11. Yeah, both are prime numbers. Okay, Nimitapata, what do you think the answer here is?
3 root 15.
3 root 15. And you can't simplify that as well. That's it. Finish. Got it? Now this one is something special. Root 4, 4 root 7 divide by 2 root 14. Make sure you write down the steps with me. First, let me write it down as a fraction. So it's easy for me to simplify. 4 root 7 over 2 root 14. What can I simplify here? 2 times tables 1, 2 times tables 2. 7 times tables 1, 7 times tables 2. Got it, Pute? Roots simplify together, whole numbers simplify together. All good? So that will end me up with a 2. Root 1 is just a 1, so I don't have to write root 1 anymore, because we know square root of a 1 is a 1. 2 times 1 is 2. And then down here it's a 1 times root 2, which is just a root 2. Got it? Now Pute, remember, denominators Pute got some rules in maths. Denominators Pute, there are two things it cannot be. Denominators cannot be negative. You never write denominators negative. If you can remember when we were doing fractions when we were small as well, I used to say if you have a 1 over 2 over negative 1 or negative 3, write it as negative 2 over 3. Denominators can't be negative. Denominator number should be always positive. Yeah. And also Pute, denominator cannot be irrational. Yeah. Cannot be irrational. Now Pute, in this case, currently the denominator we have is a rational number, root 2. How can I make a root 2 into a rational value? Do you guys know any way I can make? How?
Multiply with root 2.
Very good. Root 2 times by root 2. Let's use equivalent fractions. Multiply up and down by root 2. Then what will you get? Root 2 times root 2, that will become a root 4. Root 4 is just a 2. Do you get it? And then up here it will be a 2 root 2. Do you get it, Dominaputta? Root 2 times root 2, that will become a root 4. Root 4 is a 2. And then 2 times root 2 is 2. Then Pute, again we can simplify here a little bit. 2 times tables 1, 2 times tables 1. That will end you up with just a root 2 by itself. Did that make sense? Guys, it's a little bit of steps. It's actually nothing more than big. It's just if you get an irrational root, multiply that irrational root by itself to make it as a whole number as it is. Root 2 when you multiply by another root 2, it will become a 2. Root 3 when you multiply by root 3, it will become a 3. Like that. Make sense? All good, guys? Only when the denominator is irrational. If the denominator is rational, don't worry about anything than that. Now these two questions, Pute, your answer will be rational. You just need to divide it and get the answer. That's it. Yeah. Try to simplify these two really quickly. Work it out. You guys will get good answers for some of the questions. Alright, Pute, let's have a look at the answers here. First one, 6 root 27 divided by 3 root 3. Yeah, can we simplify this thing a little bit? 3 and 3, 2. 3 times tables 1, 3 times tables 9. So down here is a 1. Do not even worry about writing denominators anymore. So this will give you a 2 root 9. But we know root 9 is a 3. So 2 times 3, That's how much Pute? That's a 6. So the answer is just a whole 6. Correct? Next one. Root 48 over 5 root 3. 3 times tables 1, 3 times tables 16. Root 16 is a 4 and a 5. Done. That's it. Got it, Pute? Cool. Before we have a break for today, let's do this part, the last part, and then finish it off. Now, let's do this C question and then have a break today. Root 2 root 128 minus 3 root 50 plus 2 root 62 plus 4 root 2. Yeah. Dovina Buddha, I want you to simplify these. None of these things are properly written. Simplify these two roots and tell me. Niveta Buddha, simplify the first root and also rationalize the second root and tell me. Simplify the first root and rationalize the second. Yeah. Simplify means just start to divide 162, keep on dividing and take whatever you get.
So 9 root 2 and 2 root.
Very good. 9 root 2 is correct, but there's a 2 in the front, right? Did you multiply it? Yeah, you have to multiply that 9 with this 2 because there's a 2 already in the front. So that will be a 18 root 2, isn't it? Yeah.
2 root 2.
And the other one is 2 root 2. Let me think about it. Yeah, 2 root 2 is correct.
So 16 root 2.
16 root 2. Okay.
Minus 15 root 2.
Yeah, that's correct. Well done. Now, luckily all these things are root 2s, so I can quickly finish it off. 16 root 2 take away 15 root 2 will be just a root 2. That root 2 plus 18 will be a 19 root 2. That 19 root 2 plus 2 root 2 will be a 21 root 2. So your final answer will be just a 21 root 2. Does that make sense, Pute? All good? No doubts, no issues? Perfect. Alright, Pute. Then let's have a break for today. I will be sending some notes as well as questions. Okay, not like last year. Make sure that you all do the questions. Okay? Yeah, make sure to do the work. Come on, this is the final year. Not even like I don't think that you guys will get late. Maximum the lateness will be about like Jan or Feb. It will not even go until March or anything like that this year. I hope it will come back to December. Then it's good. If not, yeah, different story. Hey, it's not good to get it late. The reason is, then in case if you are doing local A-levels, no problem. But again, local A-levels also, like it will be an issue because you need to start your A-levels in April or something like that. But you can't start, like let's say that by any chance, like you went to arts field, that's a different story. But let's say that you went to men's or science, but then you got not the result you were expecting. Then you have to go back. That's a problem. Yeah, but when you go do it in December, Pute, definitely by April it is there. By May or something, you can start your A-levels without any doubts at all. Even it will affect if you're going to do London. Because why? If you have to start late, if it gets late. And the other thing, who wants to remember now with these people who are doing O-level this time, they had a new year, they totally forgot about everything. Now when they come back, they have to study all the things again for another 3 months. Yeah, they could have had a good break if they just get it done by December. Anyway, our syllabus I will be finishing just to give you a peace of mind by today September. September first week, last year I have finished the whole syllabus. This year I hope to finish same time period. And also while doing it Pute, after this year O-level, I will start up a revision class. Y'all can come into that as well. That will be helpful as well. Where I will be starting from grade 9. Grade 9 onwards, every single thing will be gone through again. So whatever you forgot or forget, it will be helpful. I'll see you guys next time then. Have a great week ahead today. Bye bye.